Dear friends, welcome to the video. Today we're asking a question that literally no one has ever been stupid enough to ask before. Can you build a valve amp for £50? So this is a circuit I've come up with. We should first have a look at how a valve works. You're basically firing a stream of electrons from one conductor to another in a vacuum. We do this by heating the cathode to over 1,000 degrees centigrade. This gives the electrons enough thermal energy to break free, which are then attracted to the oppositely charged plate. In between these conductors is the grid, and we can mediate the flow of those electrons by applying a voltage to it. Towards the back, you can see the plate that I've removed from the top side. The wire arrangement is the grid. Inside of that is the cathode, which contains the heaters. Here you can see the audio going into the grid, which controls the flow of the 90 volts, from which we can tap off our output signal. Instead of using an output transformer, we've used a voltage divider and some solid state outputs. Another transformer we've omitted is the high voltage. Instead, we're using these DC to DC converters, 3 of them in series, 30 volts each, which gives us our 90 volts. Also notable here are the valve heaters. A valve will invert the audio signal, so our inputs are also set to invert, so we get the correct phase. The dual input pot here is set to give us both attenuation and gain. Well, that's the idea anyway. Let's head over to the build stage. So the boards have arrived, rather quicker than usual. So the next job is some glorified welding. And we've got to get the case marked up for drilling. For all the holes that aren't already in the board, I've left some marks on the silk screen. And the case is complete. I've already put in the standoffs. Now we've just got to solder in the valve socket. I didn't fancy my chances of getting that centred. So we can line it up here nicely. And yes, that is a Wedgwood brass wall pot. Bit of isopropyl alcohol to clean off the flux. DC jack and the power switch. And the last bit of soldering is now complete. There's some of the finishing touches. SSL style knobs, of course. And finally, a valve. This one's an RCA black plate T16B. Right, let's plug it into my most prized possession and do some tests. You can see we're drawing about 250 milliamps. 150 of that's going to be the heaters, and it comes into emission. Here's just a visual representation of the clip-in. You can see if we drive it really hard, it goes into asymmetric. And we'll start off with some distortion tests. So we're at minus 15 dB, we're getting 0.922%. Minus 10, about 1.6. Minus 5, just shy of 3%. 0 dB, we're getting about 5.5. 5 dB, 10.5%. 10 dB, 21.5. And at 15 dB, we're getting 40.8. Yeah, if we go any more than that, we're clipping the op amps. You can see again here. Next up, we'll do a noise test. Yeah, about minus 90, which is really a lot better than I thought, to be honest. Now we'll do a frequency response test. You can see how it works. It just checks all the various frequencies. It takes a while, so I'll stick the actual thing up. Each vertical line is half a decibel. I really don't think that's too bad at all, to be honest. Right, that's it for the technical tests. Let's do the audio. So what this is really is a hardware valve saturation plug-in thing for like music production. For the tests, I'm going to use my old band because I suspect a lot of the stock music is just MIDI instruments.
Your precious things I loved so well now disown. and scattered to the wind. Your precious things I loved so well, now disowned and scattered to the wind.
Yeah, so I'm going to call that a success, to be honest. Obviously, no one's going to be using it in a professional studio, but for a fun little project, I think it's come out all right. Next time, we're going to be doing a Neve 1073, so keep an eye out for that. And if you like the video, press all the buttons if you wouldn't mind. And yeah, cheerio.